Hello everyone, myself Sheikh Muskan Shaikh. My topic for today is double pipe heat exchanger or interchanger in guidance of Professor Sri Krishna Baukar from College Delonix Society, Baramati College of Pharmacy, Barhanpur, Baramati. Let's start to our topic. Now, points that we have to cover in this topic are introduction, principle, construction, working, merits, demerits, and application. After completion of this topic, students should able to know the working principle of double pipe heat exchanger or interchanger. Let's start with introduction. The double pipe heat exchanger is in its simplest form. One pipe held concentrically inside of a larger pipe. Thus the name double pipe heat exchanger. That is, small pipe is inserted into larger one. This arrangement is similar to refill inserted into pen. Thus it is named double pipe heat exchanger. The inner pipe acts as a conductive barrier where one fluid flows through the inner pipe and another flows around it through the outer pipe, forming an annular shape. Inner pipe act as a barrier so that inner and outer fluid do not mix up. The outside or shell side flow passes over the inside or tube side flow, which will cause heat exchange through the inner tube walls. They are also referred to as hairpin, jacketed pipe, jacketed U-tube, and pipe-in-pipe exchangers. Inside, they can contain one tube or a tube bundle, but the bundle must be less than 30 tubes and the other pipe must be less than 200 millimeters in diameter. The inner tube can also use longitudinal fins, which further increases the heat transfer between the two working process. Now I'll show you in the figure. In this longitudinal shape, this acts as a fins which increases heat between two fluids. Now, principle. In a liquid to liquid heat exchanger or interchanger, the fluid to be heated is passed only once through the tubes before it gets discharged. That is single pass. Heat transfer in this case is not efficient. When few tubes per pass is desirable, double pipe heat interchanger is employed. Now let's take a look towards construction. In this, two pipes are used. One is inserted in the other, as we have seen earlier. The inside pipe is used for pumping of cold liquid to be heated. The outer pipe acts as a jacket for the circulation of the hot liquid. All jacketed sections are interconnected. Normally, the number of pipe sections is few. The length of the pipe is also less. Glass tube, standard iron pipe, and graphite construction are available. Let's take a look in the figure. This acts as a jacket for hot liquid which is circulated around the inner pipe, and this jacketed section are interconnected to each other and they are less in number. Now, standard metal pipe are assembled with standard return bends. A proper number of such pipe are connected in parallel and stuck vertically. The pipe may have longitudinal fins on its outer surface. Now, working. The hot liquid is pumped into the jacketed sections. The hot fluid is circulated through the annular space between them and carried from one section to the next section. Finally, it leaves the jacket. In this process, the pipe gets heated. while the hot fluid loses its temperature. The liquid to be heated is pumped through the inlet provided at right side. The liquid gets heated up and flows through the bent tubes into the next section of pipe. The liquid further gets heated. The same liquid continues to flow and finally leaves the interchanger through the exit point on the right side. Let's watch a video of working process of double pipe heat exchanger. A double pipe heat exchanger is one of the simplest form of heat exchangers. The first pipe shows inner pipe or tube side and the below shows outer pipe or shell side. The first figure shows parallel flow and the second shows counter current flow. At the bottom we can see temperature profile. In the parallel flow, there is a big difference between T hot in and T cold in and small difference between T hot out and T cold out. While in the counter flow, we can see there is a small difference between T hot out and T cold in and small difference between T hot in and T cold out. In this process, hot fluid enters in the jacketed section and cold fluid is released out. While in the inner pipe, cold fluid enters and hot fluid is released out. In this process, the pipe between two another pipe contains warm fluid. These are some types of double pipe heat exchanger. Now let's take a look towards merit and demerits. Let's start with merits. It's suited to high pressure application, whereas demerits are limited to low heat duties requiring surface area less than 47 meters square. Merit standardization simplifies maintenance, servicing and stocking of part. Demerit flow pattern is strictly counter flow. There is no cross flow. Merit flexibility units can be added or removed as required. Demerit as units are added on the possibilities of leakage increases because of the number of conditions increases. Let's see applications. Double pipe heat exchanger are used in many industries because of their low design and maintenance cost, flexibility and low installation cost. They are mainly used for sensible heating or cooling of process fluids in applications of small heat transfer area of up to 50 meters square. The configuration is also suitable for high pressure fluids and high fouling conditions because of the ease of their maintenance and cleaning. Reference: Pharmaceutical Engineering Principles and Practicals by CVS Subramaniam, and from Google. Video is referred by YouTube channel Minu Jain. Thank you.